Hi students. On the last exam there were some questions, or there was a question about what different tumor types look like on cytology. And I know this can be a confusing topic, so I am making another video. This one is based on picturing to learn. If you Google Felice Frankel, she is a photographer who communicates or helps scientists communicate about their science. And what she discovered is that if people can make a drawing of something and then better yet explain that drawing to somebody else, that they have really mastered the understanding of a concept. So she helps scientists communicate their knowledge or their work through pictures. And so whenever a scientist is able to do this, then she thinks that they really understand and communicate very well what it is they're trying to communicate. So I used to do this at Ross with my students, so please grab a piece of paper and draw along with me. Now, we have several tumor types: round cell, spindle cell, carcinoma. Epithelial origin tumor is the carcinoma. And so this informs what sort of shape they take. Round cell, obviously, it's going to be round. But the thing about the round cell tumor is that it has a distinct cytoplasmic border. So you can see the outline of the cell very well. And we'll talk about what would contrast with that in a moment. There are several types of round cell tumors. There are plasma cell tumors, perinuclear clear zone, maybe a nucleolus, and there are mast cell tumors. Make these purple dots in your drawing, bust out those markers and highlighters, make this pretty. Sometimes to the point that it obscures the nucleus. Sometimes you can see the nucleus in there, sometimes not. So plasma cell, mast cell, TVT, transmissible venereal tumor. The nucleus is paracentric, might have a prominent nucleolus, and it has, what characterizes it, apart from being a round cell tumor, is that it will have little vacuoles that cluster right at the periphery of the cell. And then there are histiocytomas, and these ones have, on an exam situation, a fried egg appearance. So they have a nice round cell with a central nucleus, nucleolus plus or minus being apparent or not. Sometimes they will also have the so-called buttocks cell because the nucleus looks a bit like a bum. So, round cell tumors. Spindle cell tumors are tumors that have trailing, wispy cytoplasm. They do not have distinct cytoplasmic margins. They sort of, trail off into the distance. Nucleus tends to be central. Nucleolus can be whatever size. This could be a fibrosarc. This could be a soft tissue sarcoma. This could be a hemangiosarc, would look like this, but a hemangiosarc would have a bunch of red blood cells around it and might even be engaging in erythrophagy. One thing to back up with the round cell tumors, they might be very close together. Like you might have a bunch of TBT cells all close together, but they're not actually sharing borders. They're just kind of pushed together like this. And that's okay, because when they're apart, you can still tell that they have a distinct cytoplasmic margin versus an indistinct cytoplasmic margin over here. And then for the carcinoma, because they are epithelial origin tumors, that means they have cytoplasmic borders. They have structures that are making cells adhere one to the other, like desmosomes, hemidesmosomes, whatever, all of those cadherin things, putting things together. So they might be like on histology, if you think back to first year, they might be cuboidal cells. They might have nucleoli like that. And on cytology, this appears as a clearish kind of space between the cells. So these two are relatively uniform cells. That might be an increased growth of a normal cell type. But once you start seeing differences in cell size, so anisocytosis, anisokaryosis, anisonucleoliosis, that will appear on an exam, JK, it will not. And then you can have pleomorphism, so you might all of a sudden get a big blob cell here with a giant nucleus, looking completely evil, staring back at you up the microscope. And then you might also find that there are satellite nuclei in here. And this implies that the chromatin has divided unequally and cell division didn't in fact occur. There was just division of the nuclear content, and there were little tiny nuclei because of unequal chromatin distribution. And then another thing that might happen is that cells should respect borders. They should stop growing when they reach their partner. They should stay on their own side of the bed. But in the case of a carcinoma, they've lost respect for that side of bedness. And so you might find one cell trying to spoon another cell, like that. So this is the spooning activity. And then you might also see nuclear molding. So not only do cells, they're supposed to respect what they're doing, they're supposed to respect their side of the bed. If I have binucleate cells, there might be a nuclear molding of two nuclei like that. Or we might get one cell nucleus pushing into another cell's nucleus, and nuclear molding between two cells where there's spooning, and then there's also nuclear molding of this cell and let's say that cell. So everybody is spooning in here, bad. No spooning, and if you do, you're a carcinoma. Anyhow, I hope that has helped. Do feel free to draw those out for yourself to learn about them some more before you are out in clinics when you might be looking at this kind of stuff. Take care.